if you suppose don't want to go into that simulate button, if at the right hand side you can see there is an instruments button. That is, if you want to select directly without going into the simulate button, you can select it from here and you have to drag it, right? You can have multimeter, you can have this function generator for generating different AC DC AC voltage is like sine wave, square wave, and all triangular wave. All those voltage, all those shapes or those voltages signals can be generated with the help of function generator. Then you can have power measurement, that is wattmeter. Then you can have oscilloscope for viewing, for indicating, for seeing those output signals, right? Okay, so what I am doing is I will make one circuit for Ohm's law, right? If you don't want to go in that place component side, what you will do is just, this is the workspace actually where you have to build the circuit, right? So just once right click and you will have place component, right? What you have to do is simply right click on this workspace. That workspace is basically the area where you want to work. Actually you have to build the circuit, right? So this is that area. So just once right click on this workspace and you will have place component, right? In that I want to have this one voltage source, that battery, then I will have one resistor and then one ground, right? For just verifying that Ohm's law. So what I will do is I will go to the sources, right? And then I will select power sources. In that power sources, if you see the DC power, right? So what I will do is I will just do it like, I will just press OK. I will get that DC voltage. Next what I want is I want this ground also. For getting the circuit completed, I will select ground, I will select it, I will place it in the circuit. Next what I want to do is I want to have one resistor also. So what I am doing is I will go to that basic. In that basic I will select that resistor at the left hand side, you can see, and that resistor just I am taking 1 kilo ohm. So I will just click OK. That resistor I have to drag it on the circuit, right? So this is just how to take the components from the library or the database of Multisim, right? It is very easy. You have to just drag it on the workspace. This is that 12 volt battery, right? Suppose I want to change the value of this. Double click on that that value, that is it is 12 volt. You can change it. You can have 9 volt also, right? Now what we have to do is we have to connect this voltage resistor and ground. So what I am doing is, if you see, automatically one wire will come out, right? And what you have to do is you have to connect here. If you see, there is one red dot on the screen. It makes sure that your connection is correct. So once you get this red dot, you just have to you have to just press it. So it is connected. I think it is very easy, right? Now next what we will do is the second end of resistor R1 we have to connect it to the ground connection. Same you can see, and the red dot is there, right? You have to connect it. Simple, right? And then negative end of that battery you again have to connect it to ground. So this is like a simple circuit. If you can see, there is one voltage source, that is a 9 volt battery I have taken. Then there is 1 kilo ohm resistance. Then there is a ground, right? So this circuit is completed, right? If you want, suppose you want to change the value of resistance, double click on it. You can change the value, right? Different options are there. If you want to have kilo ohm, mega ohm, all those things it is there, right, in the library. Okay. So by theory, if you see, by theoretical that Ohm's law, we have this voltage source, then you have a resistance, you have connected, it is a closed loop. The current will be given as I equal to V by R. So it will be 9 by 1 kilo ohm. So you will get current as 9 by 1 kilo ohm, that will be equal to 9 milliamperes. So that is theoretical. Now if I want to check whether it is there in Multisim, whether those results are correct or no, what we will do is we have to check the current. So what I will do is, I will, from the right hand side there is a provision, there is a button called multimeter. You have to just click it once and you have to drag it on the circuit, right? It's there, right? Now if you want to measure a current, you have to add this current source, this multimeter, in series. You have to keep this multimeter in series. So what I will do is I will delete this. How to delete is just you have to click on that, and you have that line, that junction wire will be in blue squares will be there. That is, you have selected that line and just you have to delete it, right? Now you have to connect this multimeter in series. So what I will do is that multimeter you will have plus minus, positive and negative side. What I will do is I will connect this one end of voltage V1 source, right, and then negative it will be connected in across R1, one end of R1. right? Now I'm double clicking on this this multimeter because I want to select that is current. Actually I want to find the current. Okay, so what you have to do is you have to press A, that is in amperes, right? So if you see, this is a simple circuit. What by theoretical or by Ohm's law, the current will be P by R, that will be 9 by 1 kilo ohm, it will be 9 milliamperes, right? So once this circuit is completed, what we have to do is we have to run this circuit, right? For getting how this circuit will behave and what will be the current in the circuit, what we will do is there is a green button that is for run, or if you want to have, you can go to the simulate button and you can run from there also, right? So what I am doing is I am running this circuit. I have completed this circuit and I want to analyze, check the behavior of the current in the circuit. What I will do is I will just click once. So if you see the current, you can see the value. That is 9.001 milliamperes. So theoretically it should be 9 milliamperes, and we have checked in Multisim software, it is giving us 9 milliamperes. So those results are matching, right? So we can be sure that our circuit will work. Then next step will be to design this circuit on breadboard, right? I'm not saving. Once you have completed this circuit, right, you can stop from this. For running the circuit, you have to click this green button, that is running, and if you want to stop, then you can have this red button, that is stop, right? For stopping the circuit. For if I have completed the circuit and I have analyzed, now I don't want to run this circuit, you can stop it, right? If you want to save this circuit, you can have this file, you can save as, right? Right now I'm not saving anything, right? Okay, so this is Ohm's law. Now suppose I want to analyze, or I want to do this KVL, Kirchhoff's voltage law. How I will do it? I'm deleting all this. I have selected all these things and I will delete it, right? Now first we will analyze this voltage divider rule, right? Suppose we are having multiple resistance in the circuit and we want to find the voltage across different resistances. So what we will do is, first we will right click on that workspace, we will select one component, that is place component. Then we will directly go to the sources, because I have to take one DC source, that is DC power I am taking, right? I will just click OK, right? So this is like it's giving us battery. Now suppose I want to use two resistances, I am including in my circuit two resistances, right? So that I can select directly from basic. You have the provision for resistor, click it, you will get one resistance. Again click it, you will have another resistance, right? Now we want to have that ground connection also. So what we will do is we will go to sources, and from there this is that ground connection is there, right? So we will select OK. So you'll get ground also, then close it, right? Suppose I want to rotate this resistance, that provision is there, just right click and then you can rotate 90-degree clockwise, so it will look like this, right? So now we have a circuit. I'm just connecting it. So if you can see in the circuit, there is a voltage source, right? That is 12 volt battery, and then there are two resistances, R1 and R2. That resistance value of R1 is 1 kilo ohm. Same I have kept for R2, that is 1 kilo ohm. Now I want to find the voltage that is across R1 and R2. So what I will do is I will click here on the right hand side, that is a multimeter button is there. So I will take it multimeter. Same again I will say I will take a multimeter 2, because I have to find the voltage that is across R2. So what I will do is I will take second multimeter, right? Okay, now we have to find the voltages across resistors R1 and R2. So what we will do is we have to connect it in parallelly, that is across R1 and R2. So what I will do is one end of multimeter will go to one end of R1, and second end of multimeter, that is negative, it will go to second end of R1, right? Similarly, for finding the voltage across R2, what we will do is one end of this multimeter 2 will go to R2 and second end will go to second end of R2, right? So this is very simple, I think, right? Now double click on this multimeter. What you have to do is you have to measure voltage. So it is already in voltage range, right? Again double click on multimeter 2, it is already in voltage, right? So if you solve it theoretically, what will have V1 as V2, will have as theoretically, if you solve voltage voltage across R1 will be R1 upon R1 plus R2 into 12 volts. So you will have 1 divided by 2 into 12, so you will get 6 volts. Similarly for R2, if you see, that is voltage across R2, if you want to find, what will have is R2 upon total resistance, R2 upon, that is total resistance is R1 plus R2 into 12 volts, that is supply voltage. So you will get again 1 divided by 2 into 12, so you will get a 6 volts, right? So what we will do is we'll check whether our theoretical, what we do theoretically, whether it is correct or no, the simulation results are same or no. What we will do is we have connected the circuit, now we will simulate, that is we will run the circuit. That green button is there. Okay, you will see 6 volts, 6 volts. So voltage across R1 we are getting as 6 volts, and voltage across R2 we are getting as 6 volts. So that is, those results are like we did it theoretically, so those are matching with simulation, right? Then we should approach with that mounting the circuit on PCB. I'm stopping it, right? Okay, next what we will do is we will find the voltage across, we will do one KVL circuit. What we will do is for KVL, we will have again some, this voltage source will be there, then I am taking two resistances, same as we did in voltage divider rule. We will right click on that workspace, we will have place component, we will take one DC power, right, that's DC volts. Then we will have one ground source, then we will have two resistances that I am taking. So go to basic, you will have different provisions, different resistance, capacitance, all those things are there. We will select resistor, we will click it, we will drag it on the workspace, then again drag it on the click, and then drag it, right, close it. What we will do is we have to verify the Kirchhoff's voltage law. I am connecting it to resistor R1, right. Okay, this circuit is completed. By Kirchhoff's voltage law, if I am applying 12 volt, the voltage across R1 should be 6 and voltage across R2 should be 6, because the algebraic sum should be equal to 0, right? So again taking this multimeter, I am selecting two multimeters, so I will connect in parallel way, that is one across R1. Similarly, right, I am changing the value of V1, that is I am taking as, here double click on that, you will get 9 volt. I am taking as voltage battery, that it is as 9 volt, right. Okay, this resistance is I am taking, I am changing the value in this case. Suppose I want to take, I am taking value as 2 kilo, so directly you can type 2k, right. So this is the circuit we have to follow. We want to analyze what is KVL, we have to verify KVL basically, right. This circuit is completed. So theoretically what it will be, that voltage across R1 will be 2 divided by 2 plus 1, that is 3 into 9. So what you will get as 2 divided by 3 into 9, it will be 6, right. Similarly voltage across R2 will be what, 1 divided by 3 into 9, right. So we will get as 3, that is theoretically. Double click and we will check whether it is showing correct answer or no. Just run it. So we see you will get 6 volt and 3 volt, which will add up to 9 volt, that is the battery voltage that we have applied. So in this way we can verify KVL also. Okay, I do have some, I am running out of time, so what I will do is I will show some examples that I have built in Multisim. Suppose I am having one example already solved in Multisim. If you want to open it, what we will do is go to file menu, open, I am showing one KCL, right. Okay, so this is that KCL circuit. Okay, so if you see, this is KCL circuit. I am applying that one voltage source. Then there are two resistances, that is R1 and R2, right, that are connected in parallel way. So what I want to do is I want to find the current across R1 R2, and that is how it is coming out of this node, right. And I have kept across R1 R2 and one more multimeter I have taken. So I have taken in total three multimeters, right. So this and battery voltage that I am applying is 5 volts, right. So this is a simple connection because we want to check the current law, that is KCL. I have connected that is in series in the circuit actually, that multimeters. So if you see, just running this circuit. Okay, so what we will do is if you see, there are different currents, -3 that is coming out of this R1, right. So what we will do is if you add this to -3 plus 1.1, you will get -2.273. that is the volt that current entering into the node should be equal to the current leaving that node. So this is how this circuit KCL will behave, right, in this so theoretically you can solve it and you can check it in a practical way, in the sense in the simulation way. So you can solve this circuit in Multisim software also. So this circuit behaves correct, right. Okay, now what I will do is I will simulate that RC circuit, that is again a filter circuit also, right. Just I have designed a circuit, or what I will do is I am deleting it. I will just select that what we have to do is we are simulating an RC circuit. So first we will select place component, we will select a voltage source. Okay, right now I am not selecting a voltage source. What I am doing is okay, if you see in the signal voltage source, there is a right in the center, you can see there is a pulse voltage. There is an option for pulse voltage. What I am selecting is I am selecting this pulse voltage. Why I am selecting this pulse voltage? Okay, what I am doing is I am selecting one pulse voltage. Okay, what is this pulse? Basically it is a digital signal, will have 0 and 1, right. So this is the 0 level and this is the high level. High level is plus 5 volts level. So I am selecting this pulse voltage. What I want to do is I am applying this as an input voltage, pulse voltage. It will automatically toggle between 0 and high. 0 and high means 5 volts. So it will have for certain time, it will be 0, it will be off, then again for certain time it will be on. So you can see this is like on time and this is off time, right. So and